Hello class, today we're going to learn about 3.4 factoring trinomials where the a value is not equal to 1. So let's start again at the factoring flowchart, where we're going to always look for the greatest common factor first, and that's a very first factoring technique. And then you're going to ask yourself, is there 2 terms in the expression, or 3 or 4? Remember, 4 means we're going to do factor by grouping, where you pair off each. Hello class, today we're going to talk about 3.4 factoring trinomials, where the a value is not equal to 1. So we're going to start off with the factoring flowchart again, and just refreshing our memory that we always start looking for the greatest common factor first, and we'll pull that out of your expression. Then you look at your expressions, ask yourself, is there 2 terms in it, 3 terms, or 4 terms? If there are 4 terms, you do factor by grouping. In 3 terms, there are 3 different methods. So far, we've dealt with this pathway, where we look for the sum product, and this was only allowed when the a value was equal to 1. And remember, when we have a 3-term expression, we're talking about the ones that look like this: y equals ax squared plus bx plus c. So there are 3 different terms, 1, 2, 3. And in this case, the sum product rule, it only was allowed when the a value here was equal to 1. In today's lesson, we're now going to change that, and we're going to look at the second method here, this middle one, called decomposition. And that is allowed for any trinomial, but specifically, it's meant, more people use it when a value is not equal to 1. Okay, the sum product method that we learned last time was a shortcut because a was equal to 1. This decomposition method can be used for any trinomial. So it can equal to 1 or it can equal to any other value. So we're going to look into this a bit more in depth, and I'll show you the technique down here. All right, so again, we're factoring trinomials, meaning 3 terms. And we often use that when a is not equal to 1 because we can't use the shortcut. So we're going to use this example, 2v squared plus 11v plus 5. This v could be just x if you need to visualize it that way. So we're going to recall back to when we first talked about factoring, and we said we could take 8 and break it down to its factors 2 times 4. We're going to use that same method, and we're going to use the sum product x method that we learned before. But unlike last time, we said that the top part was when we only had the c value. Well, now the top number is going to be the a value times the c value. So in this case, this is our, if we compare it back to our standard form, we need this value, and those 2 values multiplied together gives us the top number now. Okay, so if I use this example, we have 2 and we have 5. So we have 2 times 5, which then gives us 10. And it's a positive 2 and a positive 5. So it's a positive 10. Well, the bottom of the x method is the same. It's still going to be our b, meaning this value here, so that's going to be a positive 11. Then the sides of our x are the same method we used last time, where these 2 values are going to be multiplied together to get the top of your x method, and the same 2 values are going to add to your bottom number. Okay, the only difference from this method from the last method, which is a sum product, is the fact that we have a and c making this value here. Okay, so that's a positive 10, being 2 numbers multiplied by positive 10, and 2 numbers that add to 11. And those 2 numbers are going to be a positive 10 and a positive 1, right? So a positive 10 times a positive 1 gives me a positive 10. But a positive 10 plus a positive 1 gives me a positive 11. Okay, so I'm going to move what I wrote here, because what we need to do now is to take our original expression, Did not move everything. Just give me a second. Plus c. We're going to take this original expression and we're going to now use what I was trying to recall. Remember that 8 becomes 2 times 4? Well, instead of that, we're going to take what the word decomposition means to break up into pieces, just like the factoring. But what we're breaking down is the middle term. It's always this bx. So in this case, it's plus 11x. So that means that this 11x can be made up of two things. Well, the 11 was in the bottom of the x method. That meant that these two magic numbers add to 11. So I'm going to turn them 11x into plus 10x and plus 1x. Because I'm not changing the expression, so I need to somehow make this expression down here be equivalent to this expression up there. So this would work because I have a plus 10x plus 1x, and if I were to combine them, I'd get back to my 11x. So I'm going to now put plus 2x squared in front and plus 5. Okay? And by doing this, now I have a 4-term expression. And when we see a 4-term expression, what are we supposed to think about? We're supposed to think about factor by grouping. Okay? And so with this factor by grouping, I would look for a greatest common factor between the first two terms, which in this case is going to be 2 and an x. And what I'm left over is 2x squared divided by 2x leaves me just 1x left over. Plus 10x divided by 2x will give me plus 5. Then in the second expression, there's a 1x and a 5. Well, the only greatest common factor between those two values is just 1, a positive 1. It only leads with a positive, so I'm going to keep it with a positive. I can take out 1 because 1 times anything is still 1, or is the anything. So what's left over is just the x plus 5. Okay? And now, because if I did my factor by grouping correctly, I have that common bracket. And that means I can factor out that bracket and then take what's left over and put in the other bracket. And now I've factored this expression. So the two techniques you've been learning in the past 2 classes have been leading up to this big method, which is taking this larger trinomial and then, yes, we're converting it to a 4-term expression. And then we're doing factor by grouping to come back and just get 2 factors. Okay? So it's similar, and it's just taking all the pieces that you've learned and putting it all into one technique. Okay? But the reason why you couldn't use all those other techniques is because this a value is no longer 1, so you can't take the shortcut. So this is the long method to factoring. So let's try one more just to make sure you understand it. And now I'm going to use the actual variables. So I'm going to use 2n squared plus 3n minus 9. Okay? So if we go back to our method of the x, remember now the top part of the x needs the a times the c. So that means I'm taking the 2, multiplying it by negative 9, and that gives me this value here, which would be negative 18. Then I'm taking my b value and I'm putting it down here, which is positive 3. So I'm looking for 2 numbers that multiply to negative 18, and those same 2 numbers must add to a positive 3. Those 2 numbers will be a positive 6 and a negative 3, because positive 6 times a negative 3 will give me my negative, oops, what happened to my equal sign, will be a negative 18, and then a positive 6 plus a negative 3 will equal my positive 3. So those are my 2 magic numbers. So that means I'm going to break down the middle term, the plus 3n, to become the, oops, that should be plus there, plus 6n minus 3n. So when I collect these terms, they will give me my positive 3n back. And I'm just going to rewrite my 2n squared minus 9. This expression, when I collect like terms, will bring me back to this initial expression. But I'm using this for term in order to factor by grouping now so I can get to my factors. So by looking at this pair, I look for the greatest common factor, which is 2n. That leaves me with an n in the first term. Plus 6n divided by 2n will give me a plus 3. Then, in this expression, the greatest common factor is a negative 3. And remember, because this expression leads with a negative, always take the negative with it. Okay? That would make your factor much easier to deal with, because when I factor out negative 3, from this first term, I'm left with just an n, a positive n. A negative 9 divided by negative 3 will give me a positive 3. And so now I've got two of the same bracket, so that's a commonality. I can factor that out, and I'm left with just a positive 2n and a negative 3. And so if you want to check and you're kind of curious, is this truly this expression? It is. And remember, you can always expand this expression to see if that brings you back to this, and it should. Okay, so let's just do one quick check just to make sure. Or actually, why don't I challenge you to try to check it and make sure that in your very first question you do on the board, expand this out again just to make sure that it works out. Okay, and that would make sure that you've got the right factors. Let's do one more just in case, and I know this is getting long, but just to make sure we get this. So now I'm doing my x method, and I'm looking for the a times c. Here's my a, here's my c, so that's 3 times negative 5, which is negative 15. And then the bottom term is my negative 2. So two numbers that multiply to negative 15, and those same two numbers must add to negative 2. Those two numbers are going to be a negative 5 and a positive 3. Multiply gives me negative 15. But when I add them together, I should be adding, I should get a negative 2. So negative 5, positive 3. Break down your middle term of your trinomial to become a negative 5p and a plus 3p. And then I'm going to do minus 5 here and a 3p squared here. Then you're going to pair off your expressions and take out what's common. The only thing common here is just a p. So I'm left with is a 3p minus 5. And the only thing that's common here is a 1. So I'm taking out the 1. And so I'm left with a 3p minus 5. You always have to take something out. So if you can't take anything, take out a positive 1. Because now I'm left with my common bracket, which is 3p minus 5. And I have left over a p plus a 1. Okay. Hopefully these three examples have given you a good idea of how to decompose expressions. Now what I want you to do is to practice on the whiteboard. What I want you to do is you and your partner, you should divide up. There are 2 in each levels. Your partner should do one column. You should try the other column. Then switch and see if you can decipher and see if there's any mistakes from when they did theirs, and have them explain it to you if you don't get it. Okay? And then you can start off on your homework, which would be this here. And so I'm just going to move this so you can see it better. And so you have that. So make sure you do that, and there's the above and beyond. But before you start your homework, I also want you to, before you leave the class, do an exit ticket, and that's under Go Formative. So make sure you take a look at that. All right? Good luck. If you have any questions, I'm available for Math Extra Help on Wednesday at, I think it's at 9 o'clock, the usual time. All right? On Teams. And if you have any others, just give me a message on Teams. Take care. Bye.